Hey everybody, my name is Chris and I'm a tutor here at Chegg.com. I mostly do math and computer science, and in this video we're going to do an example of finding eigenvalues and eigenvectors. So here we want to find the eigenvalues and eigenvectors of this given matrix A, where A is the 2x2 matrix, 2, 3, 4, and 1. So when we find, so first what we're going to do is find the eigenvalues, and then for each of the eigenvalues there's going to be a corresponding eigenvector that we'll find. So to find the eigenvalues, we want to consider the determinant of the matrix A minus lambda I. And it's you might see this as lambda I minus A instead, and that's actually completely equivalent. It doesn't matter which one you consider. It's the same thing, exactly the same thing either way. So what is lambda I? Well, since we're dealing with 2x2 matrices, I is the identity matrix 1, 0, 0, 1, and lambda is just a scalar multiple. So lambda I is going to be lambda 0, 0, lambda. All right, so what's A minus lambda I? Well, for our case, A minus lambda I is 2, 3, 4, 1 minus lambda 0, 0, lambda, which becomes 2 minus lambda, and then 3 minus 0 is 3, 4 minus 0 is 4, and 1 minus lambda is 1 minus lambda. So we want to consider the determinant of this matrix. Okay, so again, this is the matrix A minus lambda I, and we want the determinant of this. So what's the determinant? Determinant of A minus lambda I is, so it's a 2x2 matrix, so the determinant is this times this minus this times this. So let's go ahead and calculate that. It's 2 minus lambda times 1 minus lambda minus 4 times 3. So if we expand, that's going to be FOIL. Basically, we're just going to FOIL this. We're going to get 2 minus lambda minus 2 lambda gives us minus 3 lambda, and then plus lambda squared, and then minus 4 times 3 means minus 12. And this is lambda squared minus 3 lambda plus 2 minus 12 means minus 10. Okay, so what are we going to do with this? Well, what we want to do is figure out where is this 0. Okay, so what we want to do is solve the equation, the determinant of A minus lambda I equals 0. So we're going to set this equal to 0 and solve for lambda. Well, notice we can actually factor this, which is nice. So we can factor that into lambda minus 5 times lambda plus 2, and still have equal 0 there. So this tells us that lambda equals 5 or negative 2. So these are the two eigenvalues for that matrix. Okay, so our eigenvalues are lambda equals 5 and negative 2. Now what we want to do is find the corresponding eigenvectors. So what is an eigenvector? An eigenvector is a vector v such that, let's go ahead and do this. It's a vector v such that A times v equals lambda times v. So in other words, it's a vector such that if we were to multiply the original matrix by the vector, then the result is going to be the same as if we multiplied the corresponding eigenvalue by the vector. So let's go ahead and calculate so each of these two eigenvalues has its own eigenvector. So let's go ahead and check these out one at a time. So for lambda equals 5, what we have is, so remember A is 2, 3, 4, 1. So we have 2, 3, 4, 1. And then let's say V1, it's a V, V1, V2 equals 5. So so here lambda is 5 for us, so we're going to have 5V, which means 5V1 and 5V2. Okay. So if we were to expand this out, as read it as a system of two linear equations, we're going to have 2v1 plus 3v2 equals 5v1. Okay, so we get 2v1 plus 3v2 equals 5v1. And from the other row here, we get 4v1 plus v2 equals 5v2. Okay, so let's go ahead and simplify this. So we have this system here. If we simplify it, we're going to get, let's see, 2v1 plus 3v2 equals 5v1. Subtract 2v1 from both sides. We get 3v2 equals 3v1. And here, if we subtract v2 from both sides, we get 4v1 equals 4v2. Now, we can divide both sides of this by 3, both sides of this by 4, and what we see is that ultimately we just end up with v1 equals v2. And something like this is what we should expect to happen when we're looking for eigenvectors. So what we do then is just custom to make the first element 1. So this is v1, v1 is going to be 1, and v2 equals v1, so v2 is also 1. Okay, so this is our eigenvector. This is our eigenvector for the eigenvalue 5. Okay, so we found one eigenvector. Now we have to find another eigenvector for lambda equals -2. Let's go ahead and go to the next page and do that. So for lambda equals -2, we are going to have 2, 3, 4, 1 times, let's go ahead and use w since we already used v. It doesn't really matter, but why not? Equals -2, w1, -2, w2. Okay, so again, this comes from the equation a, w, where I'm using w instead of v for no real reason, equals lambda w, with a is our 2, 3, 4, 1, or w is w1, w2, and lambda this time is -2. So that's where this -2 w1 and -2 w2 come from. Okay, so if we write this out as a linear system, we have 2 w1 plus 3 w2 equals -2 w1, and 4 w1 plus w2 equals -2 w2. So we have this system of two equations. If we simplify this, let's come up here, running out of room down there. We are going to have what? Subtract 2 w1 from both sides, and we get 3 w2 equals -4 w1. And here, subtract subtract w2 from both sides, and we get 4 w1 equals -3 w2. So it might not look like it at first glance, but these two equations actually say exactly the same thing. So what we can do on this one is divide both sides by 3, and we get w2 equals -4 over 3 w1. And for this one, divide both sides by -3, and we get -4 thirds w1 equals w2. And notice these are exactly the same equation, just with the sides swapped. Okay, so again, it's the same kind of thing that happened before, where we ended up with v1 equals v2. So it's the same kind of thing, but now we have w2 equals -4 thirds times w1. So what we could do is take the first element to be 1. So here's our w1. So what that means is w2 is going to be -4 thirds times 1, which is simply -4 thirds. And this is our eigenvector w, which corresponds to lambda equals -2. Okay, so if we go back to page 1, we're going to see that we're out of room. So let's go ahead and go to page 4 then. And so we have two eigenvectors, or excuse me, two eigenvalues, lambda equals 5 and -2. And lambda equals 5 has the eigenvector v equals 1, 1, and lambda equals -2 has the eigenvector w equals 1, -4 thirds. Is that right? Yes, 1, -4 thirds. Okay, so this has been an example of finding eigenvalues and eigenvectors for a 2x2 matrix. I hope you found this video helpful, and thank you for watching.